All right, welcome to 8.2, the Pythagorean theorem. Now, you guys already really know this theorem, at least you should. We've talked about it before, and I'm sure you've done a little bit with it, but we're going to expand on it here in this lesson. So there probably will be something new in here, even though you've seen this term and done this a bunch. So here we go. Let's just get right into it. The Pythagorean theorem, we know this, but pause this if you need to and get it into your notes. It's quite possibly the most famous and important rule in geometry. You should definitely have this thing memorized. And so, again, on a triangle, one thing that I want to highlight here is that what a lot of students do miss is this idea of what A, B, and C are. So we know that a squared plus b squared equals c squared. C, your C term, which is on the the right side of the equation here, is the term that is always across from the 90. Okay, so identifying the hypotenuse is very important in using the Pythagorean theorem. You can always identify the hypotenuse because it is the longest side of the triangle, if you have a right triangle, and it is straight across from the right angle. Okay, so there you go, the Pythagorean theorem. Get that in your notes. And this is just expanding on what I just said, where A and B in this picture, A and B are what we call the legs, and C is the hypotenuse. Okay, so here's some examples that we can work through. I'll do the first one. You guys are going to do 1B on your own. Here we go. So first of all, we're going to identify the hypotenuse. It is straight across from the 90. That is the C value, which we will call X in this case. Okay, so A we'll call 7, B we'll call 17. That does not matter. The order of those does not matter. But those two things squared need to be on one side of the equation, and the x squared needs to be on the other side. Okay, so we can say 7 squared plus 17 squared equals x squared. And you probably don't have a lot of these squares memorized. That's okay. You should know 7 squared is 49. 17 squared is 289. Okay, so then x is equal to the square root of that sum. So if you add those things together, you get 338. And then if you take the square root of 338, you end up with like 18.4-ish, so 18.38. And, they might want you to have it in radical form, so you could, keep it in radical form and just reduce the radical. There's probably a perfect square in 338, but for now, for the purposes of this, I'm just going to keep it in decimal form. Okay, so for 1b, you're going to kind of do the same thing, but again, identify this is your C value. So that's going to be by itself. Okay, so I'll help you set it up here. You guys can solve it though. X squared plus 22 squared has to equal 25 squared. And then I want you to run the math and see what you get. So pause the video and try that out. All right. And when you end up doing this, you will get, so if you take 25 and square it, you get 625. Okay. And then if we subtract 22 squared from both sides, 22 squared is 484. Okay, so we have x squared equals 625 minus 484. Which gives us 141. So x is equal to the square root of 141, whatever that is. So if I took 141 in my calculator, take the square root, I get 11.87, so I'll call it 11.9. And again, I don't know if they're going to have you, keep it in radical form or decimal form. I'm okay with either one. This particular part of the lesson here, the triples, they're not super crucial that you know them. I don't have them all memorized actually myself, but I would say that they are definitely handy, especially this one, the 3, 4, 5. And what that's saying is if you have a triangle that has a ratio of 3 to 4 in its side lengths, then the hypotenuse will be a 5. And that just applies throughout. So like if you multiplied everything by 2, you would get the 6, 8, 10. If you multiplied each one of these things by 3, you get 9, 12, and 15, and then so on and so forth. So these are common triples. I have the 3, 4, 5 memorized. That's the most popular one. But there's also the 5, 12, 13, any multiple of that, the 8, 15, 17, and the 7, 24, 25. Again, most students do not memorize those. I don't make you memorize them, but they are kind of a cheat, because if you see these patterns, you don't need to sit there and calculate it out on the calculator because you have it memorized, right? So just patterns that you can look for. You do not need to memorize these. All right, so example 2 is they would like you to try to use one of these triples that we just talked about. Again, you don't have to, but it could come in handy. If you didn't do it, this is how you would set this up, right? You'd have 20 squared plus 48 squared equals x squared. So you can always solve that way. But if we look at our handy dandy chart here and use it as a cheat, the 2048, that's going to be a multiple of this guy right here, right? So if you took 10 times 2, you get 20. If you took 24 times 2, you get 48. If you took 26 multiplied by 2, you get 52. So this would be 52. And again, you can confirm that on your calculator, which I guess I'll do for this one, and then 2b I'll kind of let you do on your own. So if you did 20 squared, you'd end up with 400. If you did 48 squared, you would end up with 2,304. Okay, if you add those together, you end up with 2,704. And if you take the square root of that, you end up with 52. Okay, so saves you all these steps if you just know the triple. You can use the chart for 2b. The hardest part is just setting it up. You have a 14 and a 50, so it looks like we're going to use that guy right there. So x is equal to 48, just looking at the chart. Okay, now, there's a couple of these where they're going to give you like 3 sides of a triangle. Okay, they're going to ask you they're going to ask you whether or not this is an acute triangle, an obtuse triangle, or a right triangle. And the way that you're going to figure that out is you're going to use the fact that, if you have an acute triangle, then your longest side, let's just say we did it like this. Well, this is going to be hard, but something like that, where all these angles are less than 90. The longest side of the triangle we will always call C. So we can test this here. If the longest side of the triangle, the C value, is less than the sum of the other two, we know it'll be acute. All right, which makes sense here. Like if you squared this guy, added it to the square of this guy, and then took the square root, if that number is less than this, we know it's acute. If that number is greater, then we know it is obtuse. And if it is equal, which I guess I don't have here, if it is equal, then we know it is a right triangle. So they're just going to have you test the sums of these things. So let me just, I guess it's easier if we just do some of these. So to do this, step 1, make sure to determine if the measures can form a triangle using the triangle inequality theorem. Remember that any 2 sides of a triangle added together must be greater than the third. So first we're going to just make sure that it is a triangle. So any 2 sides added together must be bigger than the third. Step 2 is see if c squared is greater than or less than a squared plus b squared, or I would add or equal to. Okay, because it's equal to, it's going to be a right triangle. And another side note that I'd have here is remember that C is the biggest. I don't know what's wrong with my Apple Pencil, but C is the biggest side. All right, so always keep that in mind when you're testing this. Okay, so here's an example. We have 7, 14, and 16. Notice I highlighted 16 because that is the largest one, so that is the C. And it says, first of all, determine whether the set of numbers can form a triangle. Okay, so you're going to add any 2 numbers and see if they're greater than the third. So if you add 7 plus 14, that is bigger than 16. If you add 7 and 16, that is bigger than 14. If you add 14 and 16, that is definitely bigger than 7. So it passes that test. And now we're going to classify it as acute, right, or obtuse. So I'm going to compare the c squared value, which is 16 squared. I'm going to see, is that less than, greater than, or equal to 7 squared plus 14 squared. Okay, so 7 squared is 49. 14 squared is I should have that one memorized, but sometimes I forget them when I'm in the moment here. 196. We're going to add those two together. So if I add those two together, I get 245. Okay, and I'm comparing that to 16 squared. 16 squared is equal to 256. Okay, so notice here that the c squared is actually greater than a squared plus b squared, so this is going to be obtuse. Okay, so remember that when c squared is greater than a squared plus b squared, we're dealing with an obtuse triangle, so this is an obtuse. Here on this one, notice this is going to be the c value, right? So I'm going to test 11 squared plus 60 squared. I'm going to see how it compares to 61 squared. 11 squared is 121, so I know that one by heart, but the other ones may be a little challenging. Well, maybe not for 60. 60 times 60 is 3,600. Okay, and then 61 times 61, or 61 squared, is 3,721. And again, we're comparing these. If I add these together, I actually get 3,721. If they are equal, which they are here indeed equal, then we know we are dealing with a right triangle. And again, they might, you should always make sure that we're dealing with a triangle first. So I didn't do the little test here, but you would test, does 11 plus 60, is that greater than 61? Yes. Is 11 and 61 greater than 60? Yes. Is 60 plus 61 greater than 11? Yes. So this is a triangle. These can be the measures of a triangle, and it turns out it is a right triangle. All right, so example 4b and c here, these numbers just get a little bit crazier, I guess. If you're struggling to see which one of these is the greatest, you can convert these to decimal. So you just use your calculator, and you could take the root of 3 and multiply that by 2, and you get 3.46. If you took the root of 2 and multiplied that by 4, you get 5.65. And if you took the root of 5 and multiplied that by 3, you get 6.7 something. Okay, so this is the c value. The reason I did that is just to see which one's the greatest. And you might do your test here, is this plus this greater than this? Yes, and do that all 3 times. Turns out that this is a triangle. All right, there could be a triangle, I should say. And now let's test it. So let's do 2 root 3 squared plus 4 root 2 squared, and we're going to compare that to 3 root 5 squared. Okay, so if I square this, notice the math here, you're going to square the 2, which is 4, and then when you square the square root of 3, you just get 3. So this is going to be 4 times 3, which is 12. So kind of a nice number. 4 squared is 16. Square root of 2 squared is 2. 16 times 2 gives me 32. And then here for my last one, I have 3 squared, which is 9. 9 times square root of 5 squared is 5, so 9 times 5 is 45. Okay, so you end up with 44 and 45. The c value is greater, therefore this is an obtuse. Okay, so that's an obtuse triangle. Here, for the last one here, let's see here, we have, what is this, 19. So for this one, notice here when I'm testing this, if I do 6.2 plus 13.8, remember that has to be greater than the third side, okay? But when I add these together, I get 20. So 20 equals 20. It is not greater than the third side. So since we are not greater than the third side, what this means is this would just be like, if you had these side lengths, you'd end up with just a straight line. We could not be a triangle. You can't form it since no 2 sides are greater than the third. So this is no triangle for this one.